already been discussed in the classes. So I hope you've
I
revised
was
because
having some
you
doubts.
knew the topic. Shaviz, you're asking something?
Yes, I was having some doubts from wave optics.
Just share it on the number, Learnivio's number. So in wave optics, the first topic that comes is the types of wavefront. That you should be aware of the 3 types of wavefront because that is asked in the exam. So you should be aware of the spherical wavefronts. You should be aware of the cylindrical wavefronts. And then you should be aware of the plane wavefronts. This comes separately to write in the exam. And then that also comes to draw the converging wavefront and the diverging wavefronts. All right, for the spherical, particular spherical, that wavefront also comes. Then you have the Hines principle. Hines principles of secondary wavelet. So what kind of questions you can get on Hines principle theoretical? Uh, it asks what is the assumption on which Hines principle of secondary wavelets is based. And you have to describe Hines construction for the propagation of wavefronts in a medium. That these types of questions come. Or is a backward wavefront possible? These types of question comes. So when the basis is asked, you have to tell that it is based on the principle of the wave theory of light. If in Hines principle this is asked, if in the exam it is asked, the basis on which it is based, simply you will tell the wave theory. It is based on the wave theory of light. This is the basis of it. It tells how the wavefront propagates in a medium. And you know what's the Hines principle, that each wavefront will be acting as a fresh source of disturbance, and then it will be generating the secondary wavefront like these.
Ma'am,
Then you have, yes, someone saying?
like, what's the difference between non-identical sources and identical sources?
Non-coherent. What you're saying?
Yes,
Coherent or
non-identical.
identical?
Sorry, ma'am. Like, what is the difference between slits and sources?
Slits and sources. See, when we talk about a source, source means something that is producing the wave. Whether it's the source in wave optics, whether it's the source in ray optics, source means something that is producing the wave. Most of your diagrams you have S kept where you see a wave is coming out. This is a source. Slit, when we talk about a slit, slit means a space or a gap in the sheet through which the wave is being passed. Suppose this was a continuous sheet that I had, and then in the middle I have just pierced it with a very narrow small diameter. Now I have it like this. So this is acting as a slit. That's why we write it as S1, S2 like this. This is the difference when it comes. And one more thing, class, the reflection theory derivation, refraction theory's derivation. That is very, very important. All right. I am in from Hines principle. If the numericals come, numericals will be exactly similar to dual natures, where wavelengths are used, where you have to take the ratios. Understood? One question, let us just practice. Just one question
Ma'am,
from this because other questions are similar to this. Just give
so
me a
like
minute.
slits are not sources, right?
No, no, slits are not sources. Slits are just spaces through which, see, slit is a space, slit are not sources. Through the slit, light wave will go. See, we have Young's double slit experiment. Why do we say Young's double slit experiment? Because 2 piercings have been done. So the slit, if this is one part, this appears because we have 2 slits. That's why in Young's double slit experiment, we say it's a double slit experiment. Source can be one, source can be two. Usually we have one source, but slit means this passage through which the light will go. Slit is never a source.
Okay. Ma'am, S1 and S2 are sources.
S1 and S2 here in this figure, I have shown you the slit only. Slit means slit is this. So the entire separated screen has been divided into two parts. So one part I'm saying it as S1, other part I'm saying it as S2. Otherwise, this is completely different from the source. Source is something else. Understood? When we talk
Okay.
about a source, source means something that is producing wave. Slit can be anything. See, how to perform Young's double slit experiment when you are performing it at home, or interference experiments, how these are performed. Comb is taken, the linings between the combs, between the comb. This is a comb, so even this small space between two comb, this acts as a slit. So slit is something different. Slit is just a space for the passage of light to occurs. One very small question to begin with, very easy, but it's just that once this was given and many students were having issues in this. See, this says that the optical path of monochromatic light, do not write it right now, I'll give you time. So it says that optical path of monochromatic light is the same if it travels 2 centimeter thickness of glass or 2.25 centimeter thickness of water. Right? If the refractive index of water is 1.33, what all things are given? Firstly, optical path of monochromatic light travels this much distance. All right. This much distance is the thickness of water. So thickness of glass, thickness of water, this is given, and refractive index of water, this is specified. You have to tell what's the refractive index of glass. One thing I'll tell you, which I don't think we have discussed or not, optical path, if such question comes, do not waste your time in first finding out velocity, wavelength, and converting it into back into it, and then taking the ratio. It will take a lot of time. What you can do, optical path is equal to the refractive index into the path in the medium. Path in medium. Whenever anything related to that is asked. All right. Path in medium, optical path. Now see, when we talk about the optical path for glass, optical path means optical path for glass. What is meant by optical path? Refractive index into the thickness. So let's say this is mu g, refractive index into the thickness is 2. Similarly, here also, what is the refractive index and what is the distance? And no need for conversion because this unit will be cancelled. This is already unitless, this is already unitless. Directly
Ma'am,
you will have
mu
your
is also
answer.
equal to n.
Yes,
Mu is the refractive index, right?
refractive index. I have told you in the class that refractive index is represented through n or mu. Both the symbols are valid. Both the symbols are used. So mu g will be equal to 1.33 into 2.25 divided by 2. This you can solve and let me know what's the answer. Write it. One more question from this.
Ma'am.
Yes, Shave, say.
No, optical path, how it's mu g into 2.
Optical path, see, the derivation for this is not included in your syllabus. That involves the speed, the time, and the wavelength. So that's why I'm saying that derivation is not there. Simply see, this is obtained through Snell's law only. We use Snell's law. So no need to go into the details. This is just sufficient. Refractive index into the thickness. Why we are using thickness? Because uh, into speed, it will come from Snell's law. And then speed is related with the equation of motion, that is distance and time. From there, time gets cancelled. and distance is left in place of speed. So that distance is actually the thickness what we are considering in this question. So it's actually the distance. If in your exam the term distance comes, then you can use the same formula. So instead of no need to if you specify this also, this is not incorrect. This is correct. You can write optical path is equal to refractive index is into the path in the medium. This is actually the definition also of optical path. Path in that particular medium multiplied to the refractive index of that, because that is the optical density. Refractive index tells and mentions about the optical density. So when you multiply it with the path in the medium, that gives you the optical path. So this side, right hand side, is equated for both of the things.
Can you scroll up? Done.
Yes, Tarif, correct. The answer of the first question is 1.5. Good. This is 1. Have a look at this question, class. After 1 minute, I'll discuss this. See, class, I'm discussing it. If anyone has got the answer, please write it in the chat column. Yes, Tarif, very good. See, here also you can use the same concept of optical path. How? Firstly, concept of refractive index, you all know. What is refractive index? Ratio of speed of light in vacuum to the speed of light in a medium, right? That is known as refractive index. And we have a specific term for it, that is absolute refractive index. Now, why am I discussing this here also? Because so that you know that this can separately be asked in the exam also. Absolute refractive index and relative refractive index. Both the terms, separate question on refractive index, its formula can be asked. Now, coming to this question. Thickness of the slab. What is the thickness of the slab given? The number of waves in a 4 centimeter thick strip of glass is same as in 5 centimeter thick water, means 4 centimeter thick strip of glass. That is thickness of glass slab. This is given as 4 centimeters. All right. It says thickness of water layer. This is 5 centimeter. This was 4 centimeters. So thickness of water. Thickness of water is given as 5 centimeters. And what is the refractive index of water? Refractive index of water is given as 4/3. This is the information that you have. Now, class, listen carefully. Optical path traveled by both the waves. I'm writing this also. Pay attention. Optical path means the path through which the waves will be moving, right? So optical path traveled by both the waves must be the same. See, must be the same in both the medium. In both the media. Why? Because it is given. It's already given. When the same, see, this says both have the same number of waves. So if the waves, it is given that the number of waves is same in both the medium. So optical path should be the same. Then only we'll have this condition same satisfied. Understood? That's why we have this condition same condition satisfied in both the media. Why? Because as it is
Can
given,
you just explain again?
yeah, I'm explaining this again. Given that number of waves is same in both the media. See, when we are talking about this question, look, Shaviz, other students also, listen, forget this thing. When we are talking about the number of waves in glass strip, when we are talking about number of waves, what would be the number of waves equal to? See, what's a wavelength? If this is a wave, pay attention to this class. Your previous doubt also, which you were asking, Shaviz, that also will be repeated. See, suppose this is a wave. All right. What is a wavelength? This is a wavelength. If I say one wave is equal to one wavelength, do you all agree till here? This one wave is equal
Yes,
to
sir.
one wavelength. This is clear to all of you, right? One
Yes.
wave gives one wavelength. Yes or no?
Yes,
Yes,
sir.
sir.
Right? Now see, if I expand this, suppose two waves I have taken. Now what will be the wavelength? This wavelength, again one wavelength. Then I can say two waves is equal to 2 lambda. Like this, 3 waves, 3 lambda, and so on, the numbers will be increasing. So I can basically say that number of waves, that is this 1, 2, 3, n waves we are taking, n waves, this is equal to the entire length, right? 2 lambda, 3 lambda, 4 lambda, what is it? This is the total distance, right? This is the total distance, the number of waves into the wavelength, right? Number of waves into the wavelength. Let me write it in words. This is better to understand. Listen carefully. Number of waves, 1, 2, 3, 4, whichever, into the wavelength gives the thickness. Thickness means the distance. I'm using the word thickness because it's relatable here. Now see, if I want to write number of waves, number of waves will be equal to thickness divided by the wavelength. This is clear at least to all of you. Now see, when we are talking about the glass strip, so number of waves in glass, come to the question back. Number of waves in glass. In your exam, you have to start your question from here only. Number of waves is equal to thickness. You don't need to explain this to the examiner. This was just for your understanding right now. From here straight away, either you can start from this line or straight away number of waves is equal to this. Straight away you can start. So your actual answer is now starting. Number of waves in glass will be equal to thickness, that is 4 centimeter, divided by the wavelength in glass. Similarly, number of waves in water. This is equal to 5 centimeter divided by the wavelength in water. Correct? Now, number of waves in glass is equal to number of waves in water. Same number of waves in this thick glass is same in this thickness of water. Number of waves is same, right? So it means I can equate this with this. 4 centimeter by wavelength in glass is equal to 5 centimeter by wavelength in water. So what is wavelength of glass by wavelength of water is equal to 4 by 5 simply. Centimeters will be cancelled. Now your concept of refractive index is applied. This is not a tough JEE or NEET question. It's your simple CBSE question only. These types of questions can come in your board exams. So this is right. Now see, wavelength from your already known concepts, which we discussed in the class as well, we have done this, is equal to refractive indexes ratio in refractive indices ratio. This will be n class. This becomes reverse because frequency comes in parallel. So when you put in this value here, NW by NG is equal to 4 by 5. So what is NG equal to? 5 by 4 into refractive index of water. And refractive index of water is given in the question as 4 by 3. 4 gets cancelled, 5 by 3 you get. So this is the refractive index 5 by 3 which we are getting. Mark this important. So this is only, Shaviz, which you were not understanding. This is what I have written. That optical path traveled by both the waves must be same. See, you were asking, no, how did we obtain this? Why it's written like this? In short, you can see, I have already told you the derivation, proper long derivation is not there in your syllabus. But through this, you can understand. Do you see ultimately wavelength into number is equal to wavelength into number, that is thickness. Here 4, 5, this is coming at the end.
Yes, sir.
Now see, by the derivation also something happens like this. If I write it as 5 into NW is equal to 4 into NG, this is same. Both the equations are same. So thickness into refractive index is equal to thickness into refractive index. This is known as optical path. This is known as optical path. And how it has been obtained, somewhat from here you can understand number of waves. Now, this portion is also clear. See, this is thickness into refractive index. This one term was optical path. That's why here in this question, I straight away I had written this, that you can start applying this in your answers also in the exam, because this is exactly the same what you do here. But this question was specific and special also because of the fact number of waves. This was a condition that was given. Write it down. Any doubts in this? Let me know while writing.
Can you scroll up? Can you scroll up? Can you scroll up? A little bit more, ma'am.
Shaviz, you're asking something?
No, ma'am, can you scroll up?
Scroll up. Okay, okay.
Done, ma'am.
This part, Shaviz?
Done, ma'am.
Okay, class, the numericals part we'll do tomorrow. Just let us quickly revise some more theory portions so that tomorrow we can start with numericals. The resultant waves amplitudes equation comes in the exam. So A is equal to A1 square plus A2 square plus 2 A1 A2, and the phase difference, that is cos phi, right? And intensity is directly proportional to square of amplitude. This is also very important. In different ways, this is asked in the exam. Very important, very easy. Nothing difficult comes from this equation. You have the resultant intensities equation. I is equal to I1 plus I2 plus 2 root I1 I2 cos phi. Right. So these are what? These are the resultant intensities equation. Now, yeah, one more thing. I think Chavez, you were asking also this. Coherent and incoherent sources. What exactly are these? Sources, now you understand. Firstly, what is meant by a source? Sources are the quantities or the products, you can say, or the entities which are producing the light. These are the ones which themselves are producing light. Whether this light is in the form of particle or this light is in the form of a wave, we use a complete term, that is source. Further, in wave optics specifically, the light sources are of two types. You have coherent sources and then you have incoherent sources. Now, when we are talking about coherent sources, what is meant by them? Two sources are supposed there in your system. Let's say this is one source S, this is another source S dash. Two sources are present in your system. Both of them will be emitting their own particular waves, right? So if both of these sources, suppose this is S, this is S dash, both are emitting their own specific waves. If the light wave of these two sources, which is being continuously emitted from this, both of them, suppose this has frequency, let's say nu, which is 5 hertz. This also has frequency 5 hertz. And see, both are exactly moving and overlapping each other. That is, phase difference between them is 0. There is no phase difference. It's not like one wave is moving like this, other wave is moving like this, or there would be a phase difference. No, no, nothing. If one wave is moving like this, other wave will move like this. No phase difference between them. No angular differences between them. Then you say these sources which produced these waves, these sources we call them as coherent sources. On the contrary, suppose here you have S, which is emitting its own wave. This is S prime, which is also emitting its own wave, right? And a constant phase difference is not being maintained. All right. Let's say frequency is same, wavelength also, let us assume this is same. But the phase difference is not same. Means if one wave is moving like this, other wave will move like this. So you can see 90-degree angle in this example. So phase difference, this will be variable. This changes the entire definition. So if you see the phase differences are being changed, then this source S dash, both of these are referred as incoherent sources. The sources which are producing both the waves are termed like this as coherent or incoherent. One question I wanted to you all to practice. Okay, never mind. Just note down the question. Try it yourself. Tomorrow we'll discuss the rest of the portion and the solution to the question. At least you can try it by yourself.